Scientist proposes a new universal law of biology that may explain aging. Life appears to require at least some instability. This fact should be considered a biological universality, proposes University of Southern California molecular biologist John Tower. Biological laws are thought to be rare and describe patterns or are organizing principles that appear to be generally ubiquitous. While they can be squishier than the absolutes of math or physics, such rules in biology nevertheless help us better understand the complex processes that govern life. Most examples we've found so far seem to concern themselves with the conservation of materials or energy and therefore life's tendency towards stability. For instance, Allen's rule, formulated in 1877, states warm-blooded animals in colder areas require stouter limbs with less surface area to conserve body heat, whereas in warmer regions, the opposite is true. But as with everything biological, there are some exceptions, including short-legged bush dogs found in Central and South America and the common frog. Another example of biological rules lie in repeating structures that obey mathematical power laws as they increase in size, such as the ever-expanding spirals of the nautilus shell that we see here. These are widespread across many biological systems, and again are strategies believed to conserve the use of energy and material. The way bees make hexagonal honeycomb is another clever example. Self-similar structures, including logarithmic spirals, are thought to be the most economical way to grow the size of the structure without changing shape or destroying existing structures, explains Tower. His concept, termed selectively advantageous instability, however, challenges his tendency towards the conservation of resources in biological systems. It claims at least some volatility is a fundamental biological necessity, despite such instability leading to the loss of resources, and that's because there are other things to gain. Selectively advantageous instability increases the complexity of the system, and this increased complexity has potential benefits, Tower writes. These benefits include the power to change and therefore adapt, which occurs across all biological levels, from the molecular to population. And Tower says even the simplest cells contain proteases and nucleases and regularly degrade and replace their proteins and RNAs, indicating that selectively advantageous instability is essential for life. The requirement of instability inevitably leads to a loss of energy and resources, and the accumulation of genetic mutations that may be either harmful or benign, and this is how we end up with the biological aging, Tower speculates. Yet without instability and its downsides, life would not be able to adapt and flourish through changing time and space. So we are all caught in a contradictory tug of war between a need for stability and instability, making compromises either way. Science has been fascinated lately with concepts such as chaos theory, criticality, Turing patterns, and cellular consciousness, says Tower. Research in the field suggests that selectively advantageous instability plays an important role in producing each of these phenomena. And the research was published in Frontiers in Aging, and this is on Science Alert by Tessa Koumoudos. Please leave your comments, and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.